for the day, and we're still working on reviewing equations. Now, of course, we've been giving you these monster equations with parentheses and multiple steps. And as we go through these, you'll notice that these equations turn into two-step equations and then one-step equations. So hopefully you're reviewing all of those kind of equations as we do these. So let's get started and see how we would do this particular one. We'd use the distributive property to get rid of the parentheses by multiplying 4 times that 7 and that 8. So that's a multiplication. And when we do that multiplication, we get 28n minus 4 times 8, which is 32. And all of that equals 20 plus 2n. All right, so at that point, we're going to recognize we got our great barrier here, our great wall of China, and all of the n's are going to line up on one side and all of the constants on the other. So 28n yells over to 2n, says, come over to my side. And you know when you cross the equal sign, you have to become your opposite. And it's like saying subtract 2n from both sides. In the meanwhile, you got 20 on the other side who calls out to a negative 32 and says, if you want to do something positive, come over here and be with me. And so 32 jumps the great wall or the equal sign and becomes positive 32. And then when we simplify the left side, we get 26n. And the right side becomes 52. All right, very good. So now all we have to do is give ourselves a little more space. We're going to divide both sides by 26. And our final answer is n equals 2. So if that's what you got when you tried that problem, you did it just right. Okay, now today we're going to be talking about rotations. Now, rotation is an action of turning or spinning around a center of axis, usually the origin or some other point that we designate. So we take a shape, like in this case a triangle, and just rotate it either counterclockwise or clockwise around the origin or some other point, and then describe the characteristics of that shape once it's been rotated. So there's another little indication or a little picture of something that could be rotated. And so what I want to mention is this, that if we rotate something around the origin of a coordinate system, we have to kind of remember this circular diagram. And the positive x-axis is called the 0-degree line. And so when we start rotating it, if we rotate it up to the point where it's pointing straight up, we have created a right angle. So that's a 90-degree rotation. If we go another quarter of a turn, that's another 90 degrees added on to the first 90, so that makes it 180. And if you keep going around, each 1/4 of a turn is another 90, which puts us at 270, and then to go all the way around like you do when you're doing a 360 on your bicycle or your skateboard, you go all the way around, so that would be a 360. Now, on our problems today, we're not going to be doing any 360-degree rotations. Also, to keep in mind that Alex will have a tool that will allow you to grab this arrow and rotate your object around the coordinate system. And it will recognize if you're going clockwise or counterclockwise. And if it says to do a counterclockwise circulation, make sure you do that so that you get full credit for what you're doing. So let's get started. Make sure I get the right window called up here. Here we go. And so when you're in your Alex assignment, these are the kind of questions that you're going to see, and I'm just going to explore a few of them. This first question or two, you're just going to describe the translation that is taking place here, whether it's a reflection, a rotation, or just a regular translation or a reflection. So take a look at that kind of question. If you go on to other questions, you might be asked to, like in this one, to do a rotation of 270 degrees clockwise about the origin, then give the coordinates of the marked point in the original figure. Well, first of all, the marked point we have here is 7, 2. So we would get in there and type 7 and a 2 in our first spot. Now we're going to do our rotation. So you see this nice little yellow arm here. So we basically click on it and rotate it and just kind of grab that arm and drag it around. And it helps if you're out toward the end of the line when you're dragging it. So that would be a 90-degree rotation. And it says that we're going counterclockwise, so that's backwards. So we're doing it right. 180 and then 270. So now we're going to see if we did it correctly by looking at this point and then typing in the coordinates of that dot right there, which is, in this case, is 2 and -7. And there we go. If you kind of look up here, you can kind of start to see the certain characteristics that come about from certain types of rotations. Okay, let's jump along here. Okay, you might run into some problems like this one where you're actually asked to rotate a particular figure and see if it will match up with another figure. So in this case, we're going to rotate the bottom figure onto the top one. And if we notice, it will not rotate on and cover it up or fit exactly. So this one, we're going to just say isn't possible. On this one, however, when we take our rotation, we take that figure and rotate it all the way around. We could have gone backwards in that case, but if you notice how it matches up perfectly, so that's how you would answer that question. Let's try another one. So this is another one like we saw in number 1. So this first one looks like it would be like a reflection. This also looks like it would be a reflection across the x-axis. This looks like a translation, and this looks like some kind of a rotation. Okay, what else have we got here? Okay, so when you do some of these rotations, like this one, you're going to rotate it a 90-degree clockwise about the origin, and clockwise is this way, so that's a 90-degree clockwise rotation. Now we ask ourselves, is the final side length shorter than the original? No, that's a false statement. The final angle measures are smaller than the original angle measures. That's a false statement. The original figure and the final figure are congruent. That's a true statement. If two sides are parallel in the original figure, then those sides may not be parallel in the final figure. That would be a false statement. So it's just trying to see if you understand that when you rotate something, you do not change what it is shape. Okay, excuse me. And we covered everything. So there's another one that's kind of like that. And then toward the end, you're going to get one where you we'll look around a little bit. We got to find it here. There's one where you actually have to name what actually happens. And I'm kind of trying to hunt for one like that. Okay, here we go. So on this one, it says you rotate it 270 degrees counterclockwise about the origin. And they've done that. So they started here and rotated it 270 degrees, and it's this way. And it ended up right here, okay? So now the question is, what are the new coordinates of this particular figure, and then what is the rule that applies here? So if we look at y on our first one, it was 4, 1, and our new y value is 1, -4. So 1, -4. What about our z value? The first one was 7, -2. And the new z value is -2, -7. So -2, -7. And then the last one, 3 and -7 became, this is our x value, 3 and -7 became -7, -7, and 3. So what took place there is you had the y value became the x value, or the x turned into the y value, and the y value became the x value. So basically, the y value became the x value in each case. But what happened to the x value? It became the y value, and we've got to just double check that x point because that was supposed to be a -3 as well. So the y value becomes the x value. So if we look around here, x becomes y, and y becomes negative x. So that's the rule that's at play here.